you know this, you are definitely old. Do you remember a game called Diablo? It has been released in 1996. I was 13 years old. It has this isometric view. It's a very simple hack and slash with a very dark fantasy setting. Diablo is not old, okay? It has some iconic classes and loot, atmospheric and dark music. If you are from the 80s, your heart will open probably. I will show you something. Do you want to see something? I have an original CD of Diablo 1 at home. This is not AI. This is the original CD of the game. Yes, I have this at home. Yes, exactly. Oh. Okay, perfect. Are you surprised? This CD is probably older than most of you. Okay, let's go. So I made some effort. Let me put me here at the top, because I made some effort, because I could, just make a couple of prompts and to have a working game. But I want to do something different today. I want to build the game step by step. So we will have 10 working examples. So for example, in the first iteration we'll make the setup and we will create the loop of the game. Then we'll create the walls and the structure, and every time I will type cargo run and we will see the evolution of the game. This took me a lot, because every iteration has to work. It's not complete yet, but it makes sense to stop, I don't know, after you generate the hero, after you generate the input. So this is what took me the most. So I will make basically 10 mini demos. Okay? After each of them, I will fix some typos, so hopefully I will not make many, and I will create 10 GitHub commits. So after you get this code, you can even stop after each iteration. You can even try to do this yourself, and then you can check the commit to see the difference. Orc Dev, you are here, and you will probably like this one. You mentioned about something like coding like a psycho today, and this is exactly what I will do today. So today we will code with the help, of course, with the help of fairies. Today we will code a Diablo game like this. Okay? Perfect. Let's go back here. This is... 1 second here. Julia is excited. This is the first step. In the first step, we will make the setup and the loop of the game. This part will be very interesting. We will use many things that we mentioned in the first part. Okay, I also have some surprises at the end. Yes, let's see. Okay, so it's time to check the code and to start to see Francesco suffering. If you want to wish me luck, this is the best way. It will have, of course, it will have a UI. You will see it soon, of course. It's not a console. I'm building an isometric game from scratch. I will just use, of course, I have just one dependency in this project. Just a single dependency. Okay, are we ready? I hope you are. Perfect. Let me put this here. 1 second. I want to put all the windows here. Here. 1 moment. Let me put this here. Perfect. I will put this here and here. Okay, I think we can start. Show some love to Francesco, of course. That will be great. Let's start. As you can see, I also put some effort in trying to make. Is this screen big enough? I hope is it. I hope is it. I hope that's good, big enough. Okay, let's start. No, this is a Rust rover. It's a Rust rover. Perfect. I have. Nice. Okay, good. It's 44. The font is. I see the font huge. You can try to code along. You can try, yes, or at least you can try to write some of the parts with me, for sure. Okay, let's start. Thank you so much. It's time. Just one sip of water and we will start. Thank you so much for jumping today. After each iteration, I will leave some time for some quick questions. Probably during me writing the code, I will not answer many questions unless I got stuck, of course. Okay? We will drink water, of course. A sip of mana potion. I see Miltiadis is quite nerdy. Okay, so for this project, we'll have a single dependency. The dependency is called macro quad, cargo add macro quad. This is a very simple 2D engine for Rust. There are more powerful ones, but the idea is to have just this one. Okay, let's get started. To don't get so much warnings from the Rust compiler, I want to add at the top of my file this allow dead code. We will have this dependency called macro quad prelude star. We import everything, and I want to start defining some constants. Const map, this will be the size of the map of type usize equal 20. We also want to define another constant. We will use them for the whole project. T stands for tile here. And this will be an F32, a tuple basically, F32, F32. Okay. If there is something you don't understand, at the end of one iteration, you can ask me stuff. 32 and 16. Okay. Like this. Okay. In Rust, enums are super powerful. You will have just a taste here of enums in Rust. Enum upstate. Upstate is basically the state of the app. We can be in menu, playing, or in game over. And we'll add here some logic. Okay. I want to also define a struct for this game. Struct is basically to define objects in Rust. And here we have this function new, like this, trying to get a bit familiar with the Rust syntax that returns this self, similar to a constructor here. For now, this will be quite empty. No, we don't need this here. Okay. For now, the struct game will be empty, and instead, at the end here, we'll define impl of the game, like this. Okay. Here we will have this function new that returns what? Self, basically a game. I'll be curious to know if you are already familiar with Rust or not, if you're here. Okay? Now, we are in this game. If you ever, I don't know if you ever coded in Unity 3D or something else, but we will have, usually you have a function called update. It's basically like a function that gets called continuously. function update, we have a reference, we have a mutable reference to self, which is the game. For now, we have this dt, which stands for delta time, but we are not using it for now. That's why I put this underscore. And this will return a boolean, like this. If we have true, the game is over. Otherwise, we can continue. Okay. Now we have some fake gaming logic here, like this. This is F32, of course. Now, if is key pressed, we are using here functions of macro code. Yes, I'm coding like crazy today. Key code space. I will suffer for you. Return true. I hope that this will make your life easier to understand. Okay. Otherwise we can return false. Okay, something like this. Okay. Now inside here we also have a function called draw. This function will have the responsibility to actually draw the game, draw the elements of the game. I remind you that we will draw everything from scratch here today. Okay, we have some functions like this draw text done by macro code, but that's it. That's all the help that we'll have today. I might fail miserably today. Okay, when we draw some text, we can add some parameters here. This is of course the text itself. This is for the positioning 20.0, 40, 30, and then something else is that we can also define here a sort of color like black. Okay, we can draw another text below here, and instead, for example, here we can add press space to die. This is the text that you will see. At the beginning we'll have just a demo, of course, something like this. Instead of black, we might have dark gray, something like this. Okay. Okay, nice. Now here in the main function we can have this attribute macro code that will help us. We can also have a name here, Crablo. This is like the title of the window. Async function main. We can remove this one. And now the interesting part. We can define a mutable variable for a game, otherwise this game variable will never change. So game new. And then let the mute state. This is the state of the game, and you will see now, you will start to have a taste of how powerful Rust is, because check this out. First of all, we have a loop. Do you know that in Rust there is a loop called loop? Loop is basically a while true, to make it simple. We can have this clear background white, so basically we refresh and we have basically a white empty background. And now something that I consider very beautiful. We can have a match statement, which is basically a switch on steroid. And look, check how beautiful this is. Match state, and then, for example, upstate menu. Be careful, because if you check this, you might become addicted to Rust. So be careful if you want to keep watching. Menu, enter to start. We have something like this. 100, 140, and black. This is just a simple text. And now here, if is key pressed, key code, enter, like this. We can have game equal game new. Basically, you are creating a new game here, and state equal upstate, playing, okay? Okay, now, can you see here something super cool? Check, we have an error here. Check this out. Match statement here, non-exhaustive patterns. You see what's happening here? If I make this match statement based on this enum here, if I don't cover all the cases of the enum, I think it is like this, I will get an error. This is mind-blowing. And now I am forced to do the implementation of all the variants of the enum upstate. Wonderful. Amazing developer experience. Amazing developer experience. If you get what I'm saying, you will understand that this is mind-blowing. If game dot update, we will get a frame time. We are getting this from macrocode, of course. Check it out. State equal upstate game over. Okay. And then here at the end we can have game.draw. We draw the game. For now there is not much, but we still already have a text. We still have the error. Why? Because we didn't implement, you see, you can read it here. I don't know if you can read it. Game over not covered. I love this on Rust. I really love it. Upstate. You see, I'm forced. Will not even let me compile it. If I have a game over, I want to draw the game anyway. You know, sometimes when you end your game, you still can see the game below. And then here, for example, we can draw a rectangle like this, and we can have 0, 0. Did you know that you can, instead of typing .0, you can just type dot in Rust? It's a nice feature. Screen 8, and then we can have a color, new, like this, and this color can be 1, 1, 1, 1, and 0.7. This is semi-transparent, okay? Something like this. So we draw this, and then below this we can draw a text. Game over. Let's see if I can make a mistake even on the first iteration. 100, 160. And this, for example, can be of red color for now. I want to... Copy pasting is always dangerous, but I like to live dangerously. I will risk it today. Enter to reset. And here we can have 100, like 150. This is the positioning. 20, and for example, this can be gray. Something like this. Okay, almost done. We just need to add the last if. If is key pressed, what? Key code enter. So if we press enter when we are in game over, we will start over again. So state equal upstate menu. And now at the end here something, okay, and now at the end here something which is very important. We have to call the next frame because we have to build this game frame after frame, and here we'll have something which is an asynchronous function because we don't know how much time this engine will take. Okay, I'm done with the first iteration. Now I'm allowed at least to test it with AI. Check if I wrote it correctly. And then now we will run it. Let's see if I made some mistake. Colon to the last state statement. You are right. Perfect. I think it might work anyway, but let's try. So cargo run. Let's see. Cargo run. Let's see if I can make at least the first one. Okay, we have, you see, this is a desktop application. It's wonderful. Menu, enter to start. I hit enter. Game running, press space to die. I have to fake that I'm playing. This will be replaced with a real winning condition and losing condition. Game over. Enter to reset. Okay, we are ready. Prepared. We are ready. Created a working menu. Done. Perfect. Now I will commit it, and then we will go on the step number 2. All this code will be available on GitHub at the end of the presentation, of course. Or if you want me to push it before, just let me know. Git add, git commit. I call these steps W because it stands for waypoint. This is the opposite of, we are doing today the opposite of by vibe coding. I hope I'm not crazy. Git commit. Okay, perfect. If you want, you can ask me something now. I will leave a couple of minutes if you have any question about this code. Any questions here? Commit message is just W1. Okay. We have a couple of constants with the import and an enum, a struct, which now this will be used for variables like the game, the HP, and whatever, the implementation of the game, and then the synchronous function with an infinite loop, while true, match statement. Look how beautiful is this. This is the dream. Okay? Okay. I think it's 60. It should be 60, but I'm not sure. Let's go back here. Okay. Okay, so this was the W1. Yes, I typed cargo add macro quad. I will. Okay. Just to let you see, this is a bootcamp. You are lucky here because I'm here. I will push it. No problem. Alt Z. So git push origin. You can try on your own. Okay. Git status. Git log. Okay. No. Git add. No. What's it? Oh my god. Git add. Okay. Git commit dash m. I think I made a typo. Git commit dash m. This is the W1. Okay. And then git push origin. Now it's worked. This is the repo. Okay. And then you should, okay, of course, you should type cargo run. Live pushing. Yes, exactly. Okay, let's go on the next step. I tried, Lily, to make you happy today. Here. Okay. Okay. I use loop because this is an infinite game, so it makes sense that I have a loop that checks the status of the game. It makes really sense. Now, this part is really important because we will have an isometric view grid. Okay, so we need to do something which is quite hard because usually we have, this simple matrix, a T2 grid with X and Y. But we want this. Okay, it's not that easy. We will do this from scratch with a 3D isometric view. Are you ready? I need some support here because I will create a function that does this. It's not that easy, I would say, but let's do it. Okay, let's go here. we need a new enum. We need an enum which is a tile. A tile can be of type wall or floor. Okay, and here at the top I also want to add an attribute derive with copy, clone, and also partial eq or eq stands for equalizer. Okay, we have this enum tile, and now we need a function. This is a math helper that will translate a grid to an isometric view. Okay, we have this function toScreen. This is super interesting. This is not, you can even create your own game with this. We have this uSides, y of type uSides, and then a cam which is of type tuple, f32, something like this, and then here we can return what? We will return this another tuple f32. Okay. Okay, now we need to do this. We need to make the translation. So how can we do this? Doing it in this way. X as f32 minus y as f32 multiplied by t underscore sides dot 0 plus cam dot 0. We are using tuples here. The compiler is not happy because we need to return a tuple, and here we are returning just a number, just an f32. So let's copy this below. We have here x as f32 plus y multiplied t sides dot 1 plus cam dot 1. I hope I got it right. So we create this. We'll also use vectors, but for now we have this function toScreen. Okay, now a hard part, which is that we need to draw the walls. This will be quite challenging, but let's see if Francesco can make it. I'm allowed to copy paste from my own code, so I will take advantage of this. We have the same signature basically, and now we can here define let sx sy equal toScreen. We use this function using what? The x, y, and the camera, like this. Okay. Then we need to create this setup with all this with this grid. So we can have this v, which stands for vector, and here we will have, seven different vectors too. We are basically building our world. This is super exciting. I just can't cheat, so I can't use AI here. But let's do this in this way. We have this 7 vector, which is a 2D vector, of course, sy minus 40, sx plus 32, sy minus 24. Let's see if I can make it without any typos. I don't think so, but I can try. Sx minus 32, sy minus 24. Okay, we are basically building our world. You will see this soon. Sx plus 32, sy, sx, sy plus 16. How long has it been? How long was the last time you actually coded something without AI? Copy-paste is allowed, yes. I can define some colors, like this. Here we can define colors like this. Here we can have color new, and here 0.8, like this. 0.8, 0.8, 0.8, and 1 dot. Okay. I copy this two more times. We have 0.5, 0.5, 0.5. We are also adding colors here. You will see the result soon. You just need to resist 5 more minutes. Now I will draw the faces. Draw faces. To do this, I need to draw triangles. This is a bit crazy. I have to say that this project is a bit crazy. We have something like this with colors 0. And then these are something like this, 5 and 6. I need to change this. Colors here 1. We have 3 colors here. You are using this array of colors 2 and 2, and here we have 0 1 2 0 2 3. Here we have 1 and 1, 3 and 3 also here. Here we have 4 5, 2 and 5, and here we have 5, 2, 5 and 6. Okay. I'm still not happy with this. I want to also draw an outline for A, B in something like this. We can have something like this, 0.1, something like this. I can copy this one. We're almost done. 6, 7. I really want to code this from scratch. I hope you appreciate the effort. 3, 0, 1, 4, 2, 5 and 3, 6. Okay, perfect. So based on this, we have this, and then here we draw a line. We draw a line like this. In this line, it will be done like this: va dot x, like this, va dot y, vb.x, vb.y. Okay, I think we are almost done. Draw line. We need, of course, we need the how thick we want the line, and also the color, which is black. Okay, I think we're done. No, we are not done yet, but almost done. We have this struct game, and here we can define. We start defining some stuff for this game. We have a tile map. Map here is basically 20. It's the size of the map. Okay, something like this. No, tile floor, of course. This is the type. Like this. 1 second. Tile floor map. And then 1 second. And then we have a cam of F32, F32. Okay, let me check here what's wrong. We have a map. Okay. This is like this. Because, okay, here is just the type. So this is style map, something like this. Okay? No, wait. Tile map. No, it's like this. It's like this. Like this, okay? Now, you see that here in the implementation, the compiler is getting angry because I need now to define these elements here inside the game. When I define a new game, let's say in a sort of constructor, okay? So here inside self, we can remove this and we can type let mute map equal tile floor. So by default we will have a floor, and then here map. Okay, and also here. Map is basically 20, but let's say that in the future we want a bigger map. We need in that case to do this. Okay. Okay. I want to check if I did something wrong. Something like this, I think. Okay. Let's see. Did I do something wrong? Fn game, let me up equal tile floor map. I don't know if this is a problem. We will see. And then here below this, okay, we can have a for each in 0 map. We use basically a for cycle, and here, and here we have a map. 1 second, I want to check if I did something wrong here. Let mute map. We have a tile floor. It's like this. Okay, like this. And then we have this for loop in 0 map, and then we have something like this. This is for the wall, tile wall, like this. And we are defining here something like this. 1, 2, 3, and 4. Okay. Impl game new self. I don't know why. Okay. Because I need to define the game. I can do this at the end. Okay. It's a bit upset. Let's define the game here. Otherwise, the compiler will shout at me. Map and then cam, which has basically a screen width divided by 2, and then let's make it happy. 50. Okay. Now the compiler is happy. Okay, here we have map 0i, map minus 1 I. These are the walls of the map. Map I0. I hope we'll see something at the end, and then map minus 1. Okay, and also I want to add some obstacles. Add obstacles here. I like that you are watching. Please correct me if I do something wrong. And of course here you can define any obstacle you want. I have mine, but you can change it for sure. I want to add 3 pillars in this game for now. 5, 5, 6, 5, 12, 10, something like this. Okay, like this. What here? Map y x equal to tile wall. Okay. We are almost done. I'm suffering a bit. Fn update. This is okay. Now in the function draw, I want to remove this and actually draw something meaningful here. To do this, we need to have a for cycle inside another for cycle, because I need to populate every element in this grid, in this isometric grid. So in 0 map, for x, I want to call them y and x because it makes more sense for this game. Map what here? And now here I think here you will understand, because now we can use our functions. Finally, we can draw a wall at x, y, self cam. No, of course, wait a second. No, and here, and here, if the self map so yx, the element, let's say, of this matrix, is equal to tile wall, then in this case we draw the wall. Otherwise, we might even do nothing, but I want to show at least a dot. So let sx sy equal to screen x, y, and self, and oh my god, x, y, and self come like this. Okay, and here I want to just draw here I just want to draw a simple dot, which is basically a circle. All these methods, they are from macro quad that I'm using here. Sx, sy plus 16 dot. You will see the result soon, of course. Light gray. This part is necessary. I've been thinking if this was worth it. I decided that this was worth it. Macro quad, again, here we have the game and the state. That's it. Okay, perfect. So let's see if this makes sense. Check. And let's see. Okay, it says that it's done. Let's try. Ctrl L, cargo run. Are you ready? Are you ready? Let's try. Bam! Gemini. Can you see? Maybe not now. We created a whole thing. This is done from absolutely scratch. Francesco, this was a white Canva. We built this completely from scratch. I'm proud of myself. We also have, of course, we can put some pillars here, but that's not the goal. Thank you, Sebastian. This was one of the two hard parts of the game. I never thought I would have get congratulations for building something like this, but considering that it has been done by hand, okay, nice. So here I want now to add git commit -m w2. Okay, do you want me to push it? I will do it. Git push origin. Okay, done. No, wait, Bob. Wait, Bob, we are just getting started. I'm just warming up. Okay? Now, let's start doing something cool, okay? We will start now building our hero, okay? Small note, this will not look exactly like it is in this slide, but you can use, your human imagination, okay? And here, of course, we are not focused about the models. We'll have a struct for the hero, and we'll have a position for this hero. Are you ready? Let's go with W3. I remind you that we will have 10 steps, so we are already at step 3. This will probably take some hours. Okay. Perfect. Let's go here. Right, any questions here? It looks like more like a Chaos Warrior. But it was super cool. Any question here? This part, it has been quite heavy, I would say. I hope you appreciated. Okay, we basically built this game from scratch. We draw all the walls, all the isometric view, the vectors, or the colors. This is all configurable. Okay, we draw the outline, the game, and we still have the same loop here. Okay. Okay, since we don't have any question, we can start. Okay. Okay. Now we need to draw. Okay. Now we need to draw our hero. Draw hero and monsters. We'll use this to draw the hero and the monsters. Okay. This function is called draw underscore stickman. Okay, and we'll have the same signature as the other one. Okay, we will build our model from scratch. Bam. Are you ready for this? I hope so. So we have we can have sx and then mutable sy, because we want to reposition it a bit, equal to screen x, y, and com, like this. This is the position. Sy plus equal 16. We want to move it a bit, like this. Now, I also want to add a shadow here. A shadow. A head and limbs. Body and limbs. Okay. So we also have a shadow in this game. Okay. So shadow for the hero. We can draw an ellipse with sx sy plus 3, 10, 5, 0. And then color new. This can be 0, 0, 0, and 0.2. This is the shadow of the hero. Okay, think like this. As a head, draw circle lines. These are all the functions that are used that we use that are inside the macro code. Sx, sy minus 32, 7, 2, and black. Usually I fail when I when I draw this body. Let's see. And here we have a for loop for L in, and then we are defining basically all the lines. We are building this really from scratch. This is this is really from scratch. 0 minus 25. Nobody can say that this is not has not been built from scratch. Minus 8. Here, something like this. I want to have a 5 here, something like this. Minus 20. When it was the last time you built something without AI? I'm curious, because for me it has been a while. 8. Here we have 0. Minus 8. But I think it's beneficial to do this once in a while. Yeah, minus 6. It's like a training, you know. 6. Minus 8, minus 15. This hero might look horrible. 0 and 0. Okay, here. And for all these, we will draw an actual line, like this. We'll have Sx plus L0 plus L0, Sy plus L1, Sx plus L2. We are building the body of this model. Sy plus L3, 2 dot and black. Okay, nice, perfect. 30 years ago. What we are using to get frame 4 and why are we changing state to game over? Because at some point we want the game to end. This will be that will be the last part. Because we need a game engine. We need to actually render the game. Okay, we are almost done with this part. This part is quite easier than the previous one. But we need to add the player coordinates. So px, for example, 2, py, 2, and inside this game, no, wait. Here in the struct game, we need to define x coordinate and y coordinate that are of type usides. We are defining the types here, of course. This is the struct usides, something like this. And here inside this, you see how cool is this one, that here we have the error because we are not defining the variables here, px2, py2. Okay, here we are defining this. Okay, cool. We are almost done, but of course we need, you see, it's cool because in this draw function here, we draw the player. We can just use the function draw stickman, and here it's easy. Self.px, self.py, self.come. Okay, we are using this function. And I think that's it. Let's try it out. Let's see how this looks like. Gemini says that the code is correct. Cargo run. Enter to start. Bam! We draw this by hand. Cargo run, yes. We draw this by hand. It can't move, but it's here. This is amazing. It's incredible. It's incredible. We built this freely from scratch, line by line. This is rendered in real time. Cargo R, yes. Cargo R is the shortcut for cargo run. Good looking stickman. I mean, we are not using any texture and stuff, but it's super cool. It's super cool. And this is an open source project. If you want, after this, you can pick the model of this and you can improve it. And you can make a PR. We can open an issue to improve the model. It's super cool. Super cool. Okay. Nice. I will create one more commit and then I will push it. I was scared that you had been bashed my little stickman hero. Git add, git com. Don't touch my stickman hero. Git commit -m w3. Okay. Git push. I'm pushing all the commits like this. Done. Pushed. Cool. Let's go. Now, okay, now things are getting interesting because now we need to get the input when we click on this isometric view. There might be a small. No. There is not a dot. No, fractal. That's a dot of the floor. It's not a dot on the player head. It's the dot behind because it's empty. His head is empty. Okay. So let's do this, and this now is interesting because we have this isometric view, but then when we click on any of this grid, we need to revert this to a normal grid, for example, to make some calculation. Okay? Let's do it. Let's do it. So let's go here, and now here. One second. And now, okay. And now here, we need to create a function which is the opposite of fn to screen. So fn to screen is to get isometric view starting from a grid. And then we have an fn. Then we have an fn to tile that takes in input sx sx f32, sy f32, and then a camera with a tuple. Tuple f32, f32. And then we return these usides. Okay, something like this. And now we need to do something like this. Let ax, ay equal to sx minus or minus cam.0 sy minus cam.1, something like this. So we are reverting this. What am I doing wrong here? Ah, no, it's complaining because I need to return usides. Give me one moment, Rust, please. Give me a break, Rust. Something like this. And now here we can type something like this. ax divided by t sides dot 0 plus ai divided by t dot sides dot 1 divided by 2 as usides. Okay, and then we need to do something like this below. Let's see. Okay, and here we need here we need ay. Now I always say ai because of ai. T sides 1 plus minus ax t sides 0 as usides. Okay, so this is the opposite function. Okay, draw the stickman. I think we're almost done. No, we need in the struct game to add a temporary target because when we click somewhere, we need to show that we hit that point. Usides. In here this has to be in parentheses, otherwise the compiler gets angry. And in the struct game, you see here it's telling me, hey, you need to add something here. We can have as target known. Do you know that in Rust we don't have null? Cool. We can keep this fake gaming logic, but here we can add some mouse input logic. Let's do this. If is mouse button pressed, mouse button left, here we can have let mx my equal to mouse position, like this. We are getting the input of the mouse. This is super interesting because the input and output is for any game, not just this one. txty equal to tile mx my self cam, like this. And then we want to check if the click is inside the map bounds. We don't want the player to, if we click outside of the map, it's just nothing will happen. Okay, if tx is minor than map and ty is minor than map, like this, then we have self target equals sum txty. This is how in Rust we handle errors. Okay, now we are almost done. We just need to do something when the player actually hits that button. How can we do this? For example, in the draw function, before drawing the player, we can draw the target like this. If let sum txty equal to self target, let sx as y. By the way, it's very relaxing to type this instead of letting AI to type. Why are we letting the AI to do everything for us? We are losing all the all the fun parts. Self cam, and then we can draw just a simple circle. Draw circle sx as y plus 16, for example, 6. You will see this. And let's do this yellow. I don't know if you will be able to see it, but let's do it. I think that's it. Let me check. Yes, the goal is to have coding ASMR today. The code is perfect, it's telling me Gemini. Thank you, Gemini. Cargo run. Now, when we hit somewhere on the screen, we should be able to see a yellow dot. I don't know if you'll be able to see it. Let's try. Can you see it? Can you see the yellow one? Or do you want me to change the color? Can you see the yellow one? Here. Do you want me to put it red? You can put it red. Yes. Visible. Let's do this red. This was this one. We can turn it red. Okay. Now you can see it. Okay. You see, when I click, it shows this. How to be good at writing code. Write code. Okay. This was W4. Clear. Git status. Here we have this was W3. Yes. So, okay. Git add. I'm pushing on GitHub on every waypoint. Git commit -m W4. Okay. The next one will be hard. I think I need some help for the next one. I might even take a break, a quick break. Okay. Later. Okay. So the good news for you and the bad news for me is that in this Rust Crash Bootcamp we will also have data structure and algorithms. We will do a breadth first search. We'll implement a breadth first search algorithm in Rust. I think we need a coffee break before writing this. What do you think? Coffee break? Type coffee break if you think I deserve it. Let's take a 5 minutes break, okay? Be right back. Okay, the coffee is almost ready. In the meanwhile, you can let me know what do you think, if you are enjoying it or not. I want to also make a post on Twitter. Let's make a post on Twitter. Okay. Uh-huh. Yes. No, the coffee break didn't start yet. We are implementing a BFS in Rust live in 5 minutes. Rust live, join. Okay. Let's see this one. Coffee break. Ah, best friend forever. Can I edit? No, I can't edit. Oh my god. Delete. Best friend forever. Thank you, Fractal. Second. No. No. No, spoiler. Okay. We are implementing BFS algo in Rust live. Okay. Why not? This. Why is Twitter broken? Why is Twitter so broken? You already said that. Twitter is completely broken today. I still made a typo, but this time there is this. Okay. Okay, perfect. Let's do it. Leave. Okay. Can you hear me? Let's continue. Okay. Perfect. I want to put me maybe on top for this one. So to let our player move, we need to actually implement an algorithm, because we have a player, let's say here, and then we want to go on another part of the map. You want to go in another place of the map. So we have the start, the hero. We have this sort of waves from the BFS. We find the shortest path, and then we trace the path back, and then we know what's the path. Okay. Yes. Yeah, it works too, of course. In this case, we'll implement it as BFS. Okay. I would have loved my university teacher to. I would have loved my university professor to explain this with a game and not in a super boring way. So maybe you are luckier than me. Okay. And of course, we'll avoid all the walls. The places that have a wall, they are not usable to find this path. Okay. Okay, let's do it. No, spoiler. Here and here. Okay, Alt Z. This part will be a bit challenging, but I will make it. Okay, let's do it. We need another collection from the starter library, because to optimize this algorithm we need a specific collection, which is a vectq. Okay, otherwise it will be very inefficient. After the function toTile, here we can type our pathfinding algorithm here. Let's do it. I need you to wish me luck here, because this part will be quite challenging. fnbfs, and here we have a map which is of type reference of a tile map, like this. Then we have the starting point of usides, a tuple, a goal, which is basically the point we clicked, usides, like this. And then this will return what? A vector. Basically, it will return the path, a vector of tuples of usides. Okay, something like this. I think we should do something like this. Okay, and as you can see, the compiler is complaining. Why? Because we need to return a vector. The return type of this function is this vec. So let's do this right now, so the compiler will stop complaining. You see, now it's happy. So we will return the empty vector, for example, if we don't find any path. Okay. Now here we need to define a mutable variable q, which stands for q, vec, which is a vec the q from start. We'll start this from this starting tuple, start, like this. Okay, and then we also need to keep track of all the visited cells. Do you know why? If you know why, you can type it in the chat. Why do you need to keep track of all the visited ones? If you've been studying algorithm, you know. Let's see if we find someone who can reply to this question. Without AI, by the way. You are not allowed to use AI for this this question. Visited. Start 1. And then start 0. Equal to true. Dead loop. Well done, Fractal. I'm proud of you. Because otherwise we might get, in a dead loop. the player starts looping. So we need to avoid that. Very nice answer. Let mute parent. Known map. And here map. Okay, we have this mute parent. Of course equal. Okay. And then it's complaining because it doesn't like the name parent, but it's fine. The compiler will be fine. While let sum core equal to q dot pop front, like this, and inside here we have if car is equal to goal. So if we reached our goal, we do what? We have let mute path equal to an empty vector, and then we do what? We populate it. Let mute c equal goal, while C is different from start. So until we need to get the path back. Okay. Path push. We push this element C here, and then C is equal to the new parent of C.1 and C.0. Dot unwrap is fine. Here it's fine to use unwrap. Okay, and then after this we have path reverse. We reverse the path because we need to start the player starts from the start, of course, and then we return the path. Okay, almost done, but here there is a problem. There is a problem because I need to check the 4 closed neighbors, up, down, left, and right. Okay, so for dx dy in this array that will just make this manually, in this case 0 minus 1 0 1 minus 1 0 and then 1.0 1 0. Okay, something like this. For this we can have let an x and y equal to cur.0. We are using this as a tuple, as i32 plus dx as usides, and then we have the similar one but with car.1. So it should be something like that. Car.1 as i32 plus dy as usides. It doesn't like it? No, okay. He likes it now. Let me see if this does make sense. We need a semicolon here. Perfect. Okay, and now here we need to check all the neighbors. It's here. If an x is lower than map and y is lower than map and I can do it not visited and y and x, which is basically this n cell, I will say, and also we can't create dead loops. We can't create dead loops. Equal to tile floor, because we can just move on the floor, right? Then we have visited and y and x equal true. So now we have visited this one, we can't go on this one again. The parent is equal to sum car is equal to car, it's the current, and then q dot push back n x and y. Okay. This was quite challenging, but I think we are done. I think we are done with this one. No, we are not done yet. I was joking. Because remember, before we had a target, the red dot. Now we have a whole path. So we have a path which is of type vec usides. Okay, we don't use that target anymore, and of course here we don't have the target here, but we have what? Do you know what we have here? Path back. Okay, These are all the elements of the game. Okay, we are almost at the half, almost done. If tx is minus then map and ty is minus then map, and you can make questions, by the way, and self.map ty tx is equal to tile floor. In this case we have what? Self.path is equal to, finally we can call this BFS. That's amazing. Also the monsters will move like this, self map, and then we have here self.px, self.py, not self but self.py, and then tx and ty. I think I'm done. No, I'm not done yet. I'm not done yet. I need to remove this red dot, and I need to replace with the path. We will show the path. Okay, that we should do. The player will not move yet, but after these other steps will be easier. Let px, py. By the way, I love coding like this. At least I think once a week we should do it. What do you think? Self path like this, and then let sx sy equal to screen with the reference here that py. I'm really having fun here. Self.cam like this. Bam. And then here we draw a circle. Draw a circle. Sx, sy plus 16, 4. And then here I think gold. But we'll also have gold at the end. We'll also collect gold at the end of the game. I think we're done. I think we are done. We are highlighting the path. Yes. We basically, based on the BFS algorithm, we are creating the dots. You will see it now. Just let me check if I made some dumb stuff. We will highlight the path, yes. The code is correct. Wow. Nice. Well done, Francesco. Cargo run. Who needs AI? We don't need AI. Enter to start. Okay, this is the player. If I hit here, yes, we see the path. We will see the path. Cool. If I click out, it doesn't work. Amazing. Now we'll have... I think the hard part is almost done for this project. Now we need to actually make the player move. Okay. Can you see it, how powerful this is? We are building a game from scratch. And also the monsters will do like this. Are you excited as I am? Or am I the only crazy one? I think I'm the only crazy one. From scratch. By a handmade game. Okay, cool. Git add git commit -m-w5. Okay, git push origin w5. If you have any question, you can drop it. No, git push origin me. Thank you, Simone. Thank you. No, we are not done yet. Okay, Fractal, you are really advanced. You are really pushing the boundaries of this. You are actually correct. Yes, that's a simplification I made. Nice. You can open an issue on the project. In this project, we'll have just four 4 directions, but of course they should be 8, also the diagonal. Are you a game developer? Looks cool. Okay. It was at the top. I hope it was not a problem. Okay. Okay, let's go on the next one. Now, finally, after a while, we will see our player moving. And this is super important. Take attention here, because now the player should move. We already have the path. What's the problem here? The problem here is that we need a cooldown. Otherwise, the player will literally teleport there. Okay. So we need to actually see the player moving. We actually need to add a sort of cooldown. Do you agree? We'll follow the BFS path one tile at a time after cooldown. So you can actually see the player moving in the grid. Okay, let's do it. Let's do it. So we crossed the 5 waypoints. This is the waypoint number 6. Interpolation. We will not add interpolation here, Fractal. But yes, because otherwise this will be super long. But feel free. Yeah, point chord. Yes, of course. Okay. I think this will be quite easy, because we just need to add a coordinate in the game. So in the struct of the game here, we need to add a player CD, which stands for cooldown. We'll add a player CD, which stands for cooldown of type F32. Now, when we create the game, we need to initialize this, and this can be 0 at the beginning. Zero dot. It stands for 0.0. And then when we handle the mouse input, before here we need to handle the movement. We are using here the delta time, I think, of macro quad, if I'm not wrong. Okay. 1 second. DT. 1 moment. I can see the DT. Here. Okay. In the update function here, instead of underscore DT, now we'll have the real DT. And now here we need to handle movement for the player. Okay. How can we do this? Let's do it. Player, here we have if not self path is empty. So if the path is not empty, we do what? Self dot player CD minus equal to delta time. Then time to move. Is it time to move? We need to wait. This is very similar to what I've done, for example, in Unity and other game engine. Self player CD minus equal to 0. In this case, self dot player CD equal to 0.15. We reset it basically after each iteration, and then here we do let, and then here let next step equal to self dot path 0 here, and then self dot px equal next step dot 0, And of course, let me at least copy this one, px, py, next step, while this is a tuple, and then self dot path dot remove 0. I think that's it. I think it's done. I think it's done. This is to handle the movement of the player. Let's see. Check. Now the player should move for real. If this does work, the player will actually move. Wow. I'm doing everything everything correct. Let's try. Are you ready? Are you ready? I hope so. Let's do it. I'm excited. Let's do it. So this is the player. The player is moving. The player is moving. Let's see if we try to go here. You see? It's cool. It's not perfect. You see how it's drawn? This is something that can be fixed. It's something called like the painter algorithm, but this is not the goal of this step. The player we have, and of course here we have Diablo, but this can be any game. Now I'll do this for the rest of the live event. The player can actually move now. We have done this from scratch in Rust. Okay, it took a while, but I'm also explaining step by step. Okay, I'm happy. Yes, probably you are right. You are right, Fractal. Yes, yes. Yes, there is an offset. You are right. But I need to keep it as short as possible, otherwise this live stream will be 6 hours. But I feel you. You are correct. Git add git commit -mw6 git push origin. Cool. 4 more steps. Oh, are you ready? Monsters. Again, monsters will not look exactly like this, but will implement also the logic of monsters. So we'll have some monsters of the map. At some points, these monsters will chase the player, will hit the player, will kill the player, and we can kill the monsters. That's a lot. Okay. Again, you need to use a bit of your imagination for this. Okay. Let's do it. Let's do it. No, spoiler. Here. Okay. Okay, let's do it. So let's go at the top here. Yes, now we'll get into the fun part. So here we have for the monsters, we can have a struct monster. And of course here we might have different monsters. Here we will keep it to the bare minimum. It's just to showcase the potential, of course. Y usides HP I32 and CD I32. Okay, this is the struct of the monster. We need to update the draw stickman function because I want these monsters to look different compared to the player. We need to add one more parameter here, like enemy, which is like basically is a boolean, just to differentiate the monsters and the player. We will leave the shadow here, but I want the enemies to have a different head. So if enemy will have something, otherwise, so if we have the player, we'll draw this. So in case we have enemies, I want to do this. I want to draw a line which is which is sx minus 5 with dot, sy minus 32, sx sy minus 30, 2 dot black, like this. Draw line sx plus 5. You will see this soon. Exactly, fractal. Exactly. Enemy. In the struct of the game, we can have an monsters. No, this is we can have monsters, which is of course a vector of monster. Look how beautiful is this structured. In the game here, you see I get an error here because I need to add this vector of monsters. So here we initialize this vector of monsters. How? Monsters, for example, like this, back, and here we can initialize some monsters. For example, monster. And here we can even create some super monster. I will create same monsters. 8 HP, 30 CD, 0. Okay. I will create three monsters with the same HP and the same CD. Cooldown. I think the cooldown is for the attack. 12, 4. But here, for example, you can also put different numbers. You can have different monsters. Okay, so we have these 3 monsters here, and I think we're almost done. What do we need to do? We need to draw the player and the monsters. You see, I get an error here. Why? Because we added the boolean, so this is false because the player is not an enemy. And then draw monsters, but here we need to draw them all, so it's not just one. So here we have a for loop with m, which stands for monster, in at self.monsters, like this. We can use the same function, draw stickman, m.x, m.y, self.come, and then true. And yes, we'll use the same function to find the player. I think we're done. I just want to visualize the 3 monsters here now. Okay, so Ctrl+C, check. It's going quite well, by the way. Let's see. Let's see if I did some mistake. I've been coding everything from scratch so far. I didn't cheat. The code is correct. Wow, well done, Francesco. Cargo run. We should see 3 monsters, and we should be able also to still move as a player, of course. Wow. That's cool. I can't do much. I can even, pass through a monster, but this is intentional. We will fix this, no worries. Because probably when we are here and if we click on an existing monster, we want to do something. Okay? That's super cool. Look how cool this is. It's cool. Cool. Nice. So, let's do git add, git commit, -m w7, git push origin. Do you have any question here? We need just 3 more steps and then we will be done. Okay, I will finish all the steps. Someone signed up for the bootcamp now. Love it. Always hitting the deadline. Okay, Ctrl+T. Okay. I love this part. I loved this part. This is the combat. Combat will, spoiler, will also have floating text. Not perfect, but floating text. So we'll have the hero with the hit points, the monsters with hit points. We'll have some logic, sort of turn, but it's so quick that basically you will not feel like it's a turn. We'll check for addition fools, calculate the damage, apply the HP, spawn floating text. So this is probably my favorite step now, because we will add some cool stuff here. I think that now we'll add just the player logic. So this is just the logic for the player, because I want first to implement the damage for the player and then the damage for the monsters. Okay, let's do it. Let's go here at the top. I really enjoyed doing this. By the way, how many lines of code did we write so far? Not much. 306. Okay. More than 300 lines of code, but manually. Okay, nice. Let's go, and on the monster, we can change the cooldown to F32, because we might need it, and then I also want to add a struct for floating text. Yes, we'll also have a floating text in this game. Struct DMG text. What do we need here? An X, F32, a Y, F32, a damage, which is basically the number we want to display here. This is just a displayer, of course. And then a life. I call this life, but this is not the life of the player. This is the lifetime. It's the lifetime of this floating text. Like a floating text that lasts 2 seconds should have life 2. I think we'll have 1, but we will see. Okay, BFS, we have done it. I'm happy. Draw wall. We just need here on the game after monsters to have also text, which will be a vector of damage text, something like this. And then in the game here, you see that I always get an error. This is, I think, a 0 dot, because we changed this to float. Okay, and then here we will have text, and this at the beginning will be empty, of course. These are like the floating text for the fight. So at the beginning we don't have them. Now in the function update, we can keep the skip rest. I want to update the text animations. So we will have self. Here we'll use a super cool function, self text dot retain mute, and here we'll use a closure. Do you know closures in Rust? T dot life minus equal delta time, t dot y minus equal 20 dot multiplied dt, and then t dot life is greater than 0 dot. Okay, perfect. Yes, this is a super cool project, yes. Okay, so we have updated this text. This retain mat, if you're interested, I can explain what is that. Now, if mouse button pressed is left, we have this. We check, and this is correct. Now here we need to implement all the logic here. We need to implement the combat logic here. So I think the best would be to update this one and having here the combat logic for the player. Combat logic for the player. Because the player can attack or move. Okay. So if let sum y equal to self dot monsters dot iter dot position, monsters dot iter dot position, and then here we'll have another closure m. I hope you're familiar with the concept of closures, and x. This is not an x. I forgot to add this. No. Let's do this again. Here. I forgot to add a line. Let's do it. Here we need to add a line. Let n x and y equal to self dot path 0. Okay, and below we need to add the logic. So if let sum I equal to self dot monsters dot iter dot position, and here we have a closure with an m dot x equal n x and m dot y equal to ny. That's it. In this case, we do what? We attack. Okay. Otherwise, we will move. Let's do the attack first. Self, and this part will be super cool. Damage monster. Thank you so much, Atarva, for gifting the memberships. Self.damage monster. Y 10. And then we stop moving, of course. So we stop moving if we attack. Self.path clear. Of course, we need to write this function. Else move self.path dot remove 0. Remove the element in position 0, and then self px equal to an x, and since I'm lazy, I'll just copy paste this. Self py equal ny. Okay, we have an error here, but this is quite expected since we didn't write this function. So we actually needed to write this function. So this is a helper to damage monsters. Okay. This function, it will be called fn damage monster. Thank you so much for the IDE. Ampersand mutable self idx usides amount is basically the damage of the player. Of course, here we should add weapons and stuff, but in this case we'll just have this self monsters idx dot hp minus equal amount. You reduce the life of the monsters, and then something super cool. We spawn the text. We spawn actually the floating text. So we have let sx sy equal to screen. Then here self dot monsters idx dot x. And then self dot monsters idx dot y. And then I think we're almost done. I don't think we need two of these, but here we need the camera. Self.cam. Okay. Nice. And now here we need to do what? Here we need to update the floating text. So self, the final effect you will like it, I'm sure. Self.text.push. Push what? An object of type damage text. Here we have it. Let's use it. XSX Y. We have a small offset here, -40. Damage, which damage here is just the amount we display. Okay, we are just displaying the amount here. And again, life is the lifespan of this text. It's like how fast this scroll text works. We are almost done, but I want to add also the kill logic. Let's add it. Let's kill some monster. I think you will understand this, because if self.monsters idx, which is basically the monster attacked, .hp is minus or equal than 0, self monsters.remove idx. Is it clear? Self monsters remove. I missed a semicolon here. Okay, F and draw. We are almost done. Now here I want to draw the floating text. Let's do it. For t in ampersand self monsters no for t in ampersand self text, we want to update the text here. We can do something super easy here. We can do draw underscore text, and then here we can have a format like this, minus like this, t.damage, which is the damage we want to display, t.x, t.y, 20, and red. I think the final effect, it will be quite cool. So far so good. I'm loving Rust. Thank you, this makes me really happy. I think we are done. We can kill the monsters. I want to check. Let's see. Let's do it. I'm pushing on GitHub after each step. Okay? So far I'm doing quite well. Just a bit slow, but it's fine. The code is correct. Well done, Francesco. Well done, Francesco. Cargo run. Let's see if we can kill some monsters. Are you ready? Bam. Monsters still can't do anything to us, but let's see if I can kill it. Bam, bam, bam. Yes! Oh my god, it works. 1, 2, 3. It works. Bam, bam, bam. Nothing happens, but this is cool. This is the logic to attack and kill the monsters. Cool. Amazing. Amazing. Clear. Git add. We need just 2 more steps. Git add, git commit -m w8, and then git push origin. 1 second. Pushed on GitHub. I want to go here. I want to go here. You missed attack logic. Player proximity is taken into account. Attack logic, you mean for the monsters? Wait, let's see if I find it. Otherwise it will not work. I think it's in the update. This is the logic for the player. Here. Combat logic for the player. If let sum, if this is the position of the monster, we damage the monster and we clear the path. Otherwise we move. Make sense? It's, of course, it's super simplified, but it works. It's oversimplified, I agree, but it still does the job. Okay, this is the logic, combat logic for the player. It's here. You have a specific commit for this one, which is the W8. Okay, is it clear, Fractal? Cool. Almost done. Almost done. Okay. Let's go here and let's see what we need. To tile. Okay, for the monsters, I want to add another helper, which is to calculate the distance, and we'll use the Manhattan distance here, which is of course a simplification, but it's fine. So we have this function dist, which is p1 usides p2 usides like this, and I32, and then here we have p1.0 as I32 minus p2.0 as I32 dot abs. We are calculating the distance just in this way, and then I think, oh no, and then something super and something very similar, which is will be this one, p1.1 as I32 minus p2.1 as I32 abs. Okay, this is to calculate the distance. Okay, BFS. I'm happy that we made it. I think we just need now to add the the HP of the player. We'll add them directly inside this struct game I32, like this. This is the HP of the player, because the player can actually die. And here, after the text, we can have HP 100. Let's give 100 HP to the player. In the function update, I think we can now remove this fake game logic. Okay, so if self dot HP minus equal to 0, return true. So if the player has 0 each point, we return true. The game is over. Okay. Okay, if combat logic. Okay. Now we need to add the monster logic. Monster logic will be here. We are almost done, by the way. Almost done with this bootcamp. We just need 2 more steps. Okay. Okay. We need to calculate the occupied spots. So enemies they don't stack. I don't want the enemies to stack on each other. Okay. So we need to have let occupied which is of type vec. For now we don't need, I think that's fine, equal to self.monsters.iter map, and here we can have a closure of like this, and then here m.x, m.y, and I want to also chain this with the current position of the player. Second, let me see. No, chain std iter once, because we have just one player. It's like this. Iter once, like this. Chain std iter once. I think it might be correct. Let's try. Self.px, self.py. Okay. And then dot collect. I did some mistakes. Let me try to understand what I did wrong here. I think it might be this. Let me see. No, this is correct. Chain std. No, we are not calling the method here. Iter once, self.px, self.py, like this. Oh, okay. Collect. Okay, this was quite hard to type. Okay, now, okay. So here, in this case, this should be more readable. So we have these monsters, we iterated through the monsters, we have the map of all the monsters, and then we chain with just once with the position of the player, and we collect everything inside a new vector to have basically a vector of all the occupied tiles, the occupied spots. I think this solution is very elegant, very, very elegant. And then, almost done. For I in 0 self dot monsters dot len here we have self dot monsters I dot cd minus equal to dt, and then if self monsters I dot cd is minor or equal to 0 dot self, I will copy this, I'm lazy, self monsters I dot cd is equal to 1 dot. Okay, the monsters will be slow. The monsters will be slower than the player. And then let mx my equal to self dot monsters y dot x, and then self dot monsters dot y dot I dot y. Like this, yes. And then we have let d equal to the distance that we calculated, the function that we wrote before, mx my, and then self.px, self.py, self.cam. Okay. It doesn't like it. Why? Let dist mx my self.py, self.px, self.py. No, we don't have the cam here. I added the cam, but we don't need it. self-px.self-py, like this. Yes. And now we need to decide what we want to do, because depending on the distance, we'll have different things. So if d is equal to 1, self.hp minus equal to 5, and then let sx sy equal to screen self.px, self.py, and self.cam. Okay? Something like this. .py. Okay, almost done. Almost done. And then self.text. We need to update the text. .push. We push what? We push a damage text, basically a floating text here. Damage text. X sx y sy minus 40, damage 5. The monsters, they do just 5 points of damage. It might be more. If we want to make the game harder, we might increase this number. Otherwise, what? Otherwise, the monsters should chase the player. I think that this is not correct. It's like this. Else, we chase the player. Chase the player. The monsters will chase the player here. So let path equal to BFS. And here is cool because, as someone mentioned, we are using the same function to let the monsters chase the player. Super cool. We are reusing some stuff. mx, my, self.px, self.py. Okay. And then if path.len is greater than 1 and not occupied, so we are not going into an occupied square element of the grid, dot contains at path 0 self.monsters i.x equal path 0.0. I wrote here. Yes. And then here self-monsters y, self-monster I, y, path 0.1. Okay? I think we are done. Are we done? No. We are not done yet, but we are almost done. We just need to do what? We need to draw an HUD. What is an HUD? If you're a game developer, you know what is that. It's a universal vocabulary. Do you know what is that? Have you ever done a game development in your life? Draw text and format. HP self.hp like this 20 screen height minus 40 dot 30. We're almost done. 30 and black. Is it clear here what we're doing? Do you know what this HUD is? You should. We are almost done. We just need something on the game over. So on the game over, let's keep this as it is. We can leave the game over, then enter to reset. But before maybe enter to reset, I want to show something here. I want to show the final HP on the screen, for example. We can have, for example, something like this. draw text after game over, draw text. Let's do this. Format HP. We want to show the final HP. HP. This might even be not perfect. It might even be go below 0, but it's fine. HP. Game HP. 100. 160. 30. Black. Okay, like this. We are done. I think we are done. I think we are done. Let's check it. Let's check it. Check it. Let's do it. If this does work, let's see if we have an error here. The code works. Let's try this out. If this does work, cargo run. Let's do it like this. Menu start. Yes. Okay, the monsters are chasing the player. Ah, cool. If I do this, oh, can you see? I'm getting hit. The logic is not perfect. Cool. It works. Bam. It's quite good. Not bad. You see there is a little glitch in the... Okay, I'm not getting the victory. The deserved victory. No, I needed to run this again. But I think that if I get killed, I should see the game over. So I should have the game over thing. Let's die. I'm using macro code, but I'm doing most of the things on my own. You see, it's not perfect. Let's see if I die. Bam! Game over. Bam. That's amazing. That's amazing. It's really amazing. Okay, so now git add, git commit -m-w9, git push origin. Okay, it's fine. Thank you. Thank you. We need just one more step and then we will be done. Quite long, more than 2 hours. Okay. We need just one more step, which is that we want to add victory condition, so if the player kills all the monsters, they win. And I also want to add that you can collect some golds here. Okay? You can add UI, score gold, and victory game over states. And then we will be done today. And we'll have a complete game with all the logic, the menu, and stuff. I also have a couple of surprises for the end, because I have prepared something on the side, I'll say. There are 2 surprises at the end. So, map, app state, derive. Okay, we are almost done. So let's go here. In the damage text here, we don't need to do anything, but I want to make a sort of hack. So negative damage will be treated as gold collected. You will see this. This is a hack, of course. This is done. Stickman, draw wall, draw lines. So let's go here at the in the game. So after the HP we'll have gold, which is a vector. We'll have something very simple here. Gold, it will be a vector of basically positions, the positions of the gold, like this. and then we have a score. The player will have a score now. So not just HP, but goal, but score. In the game here, after the monsters, we can have a score for the player, which is 0, and then I can, similar to the pillars and the monsters, we can create a vector of gold, which will be something like this. 3, 3, they are U-sides, not floats. 2, 3, 4, 5, 3.3, 10.2, 10.2, 16.5, 6, no, 6, 14, and then 17, 17. I'm putting some gold on the map, okay? And now, in the update function, we have the victory condition. Victory loss condition. So, if our HP are smaller than 0, or self what? Self.monsters.isEmpty. So if there are no monsters left, we return true. So the game is over in this case. And return true. After the move of the player, we can collect gold logic. So, and this is generic, like in this case we want to get some gold. If let sum I equal to self.gold dot iter dot position, no, iter dot position, and then here we use again a closure g, and then g is equal to self dot px and self px self py, like this. Yes, self px self py. We do what? We remove the actual gold, otherwise we will be able to pick this multiple times. We remove the gold, and then self.score, this should be obvious, score plus equal 100. Okay, and then we spawn a green text because we want to show that we collected some gold. We will see this. Let sx sy equal to screen self.px self.py self.cam, like this. And then self.text push. We push, and this is a very powerful way because all the texts that we want to show, they are pushed into this array of damage text. Damage text. And here, of course, we can do something cool. X sx y sy minus 40 40.0, and then damage minus 100, which is basically a hack to showcase a positive number, and then life it's fine that is 1. Okay, life 1, I think we are done. This is the last one. No, I think we are not done yet, but I think we are very, very close. Damage monsters. Okay, I want to add some logic. I want to add plus 50 bonus if I kill a monster. Self.score plus equal to 50. Something like this. I agree. And then in the function draw, we draw the wall. And here I need to add the logic to draw gold or that small dot. So here, if self.gold.contains a reference to x and y, so if there is gold, let something like this, and then we draw a circle, which is a golden circle. Basically, we are drawing the gold here as x, as y. This can be a 6, and it can be gold, for example. And otherwise, we do this. Basically, here we are drawing the gold. No. Okay. I think we are almost done. 4T in self-text. And here's something cool, because now here we can show the negative number red if we are showing text that we are killing or damaging a player or a monster. Otherwise, we show a green text. So if the damage is smaller than 0, we draw a text. Let me do like this, otherwise I forget. Okay, so here we draw text format with a plus, and this is funny, is minus t.damage, and the color will be green. I understand that I'm using a hack here, okay? And otherwise we'll draw this thing. In the HUD, we'll have one for the HP and one for the score. So here, format score self.score. We're almost done, by the way. Score 20, screen white, minus 70, 30 black. I think we are done. No, almost done. We just need in the game over logic. After we draw the game, we draw the rectangle. We need to add the logic here. Basically, we want to show either if we won or we lost. Okay, so here we'll add victory, and this is for every game. Victories versus defeat logic. So the game is over if the player has less than 0 HPs or if all the monsters are dead. And now I think you can guess what will happen here. Get MSG and color, because I want also the color to be customizable. Let's go the extra mile. If game.hp is greater than 0, we define this tuple message call as victory. You see how powerful is this? It's very expressive here. Else, we define a tuple based on some condition. Otherwise, we'll have what? Game over red. We are basically customizing the message based on the condition. Super cool. Okay, now that we have this message with a color, we can just draw the text that instead of game over is what? Is MSG screen 8, and then instead of red we'll have here what? Call. Bam. I love it. maybe this is a bit different. Let's put this screen width divided 2.0 and then minus 0 minus 100 and then screen height divided by 2 divided by 2 and then 60. Okay, I think we are done. Draw text, message screen, format HP. Wait, we are almost done, I think. We don't want to share the HP here. Doesn't make sense. Let's, instead of HP, let's put here final score. Doesn't make sense to show the HP of the player. This was a placeholder. The score makes more sense. Okay. Game score. Here also I want to change it. Let's put this here. Almost done, by the way. We are almost done. Almost done with this Rust Crash Bootcamp 2 with you. Game score. This is not mandatory, by the way. Screen width divided by 2 minus 80. And then screen height divided by 2. This is just to add an offset, of course. It's not mandatory. But let's see. If we can make it cool, it will be nice. Black. Okay. Oh, okay. Nice. And then draw text. Enter to reset. Almost done. Here. Screen, because this can also be defined by the screen. 2.0 minus 80. And screen height divided, because I want this to be basically in the middle of the screen. It's basically a relative position. Plus, it's basically I'm doing CSS. 20. Gray. It doesn't like it. No, wait. 2 plus 90. Screen width. Like this. Okay. I think we are done. There might be some small typo. If we skip rest up state menu. Okay. Let's check it. If this is done, we will be done. Just 2 hours and a half. Not much. Not much. Let's see if I did some mistake here. The final version looks perfect. This is what is telling me Gemini. Okay. Cargo run. Let's try it out. No, it doesn't work. Okay. Menu, enter to start. Let's do it. Okay, you see I can move. My score is 0. I can collect golds. Amazing. I can go here and I can fight the monsters. Wow. There is some glitch, but it's fine. Let's kill this. I want to die. I want to die and then I want to win. Let's keep the win at the end. You see the floating text? I'm slowly dying. And then I will show something, by the way, in the end. Game over with a final score. Enter to reset. Bam. Enter to start. This looks so amazing. It looks amazing. This project is over. Victor with final score. There is a little offset, but I will keep it. I think I'm happy with this result. Now, I want to take 2 minutes